Okay. Yeah. How did you do on the test, Kaylee?
I got a B on it.
Mm,
Nice.
okay, though.
Yeah, I wanted an A, but you know. How
Mm,
how did you guys do?
I did okay.
74.
Oh man.
I got a
No, it's
90.
okay. That's passing, so I don't really. As long as I'm passing, it doesn't matter, I guess.
Yeah, that's good.
Get degrees.
How about you, Danielle? How'd it go?
Good. I got a 90 on it, so I felt pretty good about it.
That's awesome.
Yeah. Some
I
of
did it right after we were done with the review because I had
me too.
a busy weekend and I think I should have studied more. So,
Yeah, I did it right after as well, just because I wanted to get it over with.
yeah.
Okay, so should we go ahead and get started? I kind of have to do a lot tonight, so.
Yeah, and I gotta go get my wife here pretty soon.
Okay,
Okay.
let's do it. First, do you guys want to talk about? I think we just have to talk about the group project. I mean,
Oh, yeah, yeah.
we don't. I don't think we have to fill anything out or anything. We just have to. The first thing's not due until Saturday, so we can talk about it more on Wednesday. Remember Miranda's here, but
So, I was reading through it and she wrote that she doesn't want you to do something like super simple like M&Ms.
mhm,
She wants something like some that's a little bit more applicable.
yeah,
So, is there something that like we would like to do that's applicable to our majors or something?
yeah, we could do that. Um,
What are you guys majoring in?
exercise physiology.
And mine is food science.
Food science, and I'm exercise physiology too.
So maybe we could do something like exercise phys related.
Okay,
Like an exercise statistic.
yeah,
Or
Maybe
maybe
we
like
could
a. Oh, sorry, go ahead.
I just an idea popped in my head. We could do like the effects of sports drinks or something if we can run faster or something. I don't know.
That's what
yeah,
I was thinking, because since me and Danielle are exercise phys and you're food science, we can like find something that. Because obviously you can mix those two together, like what you said with like food, or with like a sports drinks or diet or whatever for athletes.
yeah.
That'd be cool.
That'd be a good one. And that's not super like obvious. I like that.
I guess we just have to figure out like we'd have to figure something out that wouldn't be way too complicated because we wouldn't want to like test like cholesterol levels or something. Like that'd be way hard. So
Yeah.
maybe something more like if they I don't know, feel like they can I have no idea. How could we do that? Maybe we could Google it or something.
Yeah.
Hmm.
Um I don't really know what we're supposed to do. All members of the group should help provide ideas. Blah, blah, blah. Journey. So are we creating a study and also testing the study?
Hold, I'm not sure. Let me see. I just remember like the M&Ms part stood out to me where I think they actually did the study with the M&Ms.
Okay.
But I could be wrong because that happens a lot sometimes.
Let's
Let me
see.
check.
You and your group will complete a final project together. The project is divided into 7 steps. The 7 steps you have seen in the reading: the design, the study, collect the data, describe the data, make the inference, take action, plus with the PowerPoint presentation, and evaluate your group members.
So I guess we're just supposed to be doing each step during our group meetings, right?
Yeah. Design the study, but we do have to collect data, right?
Yeah,
Yeah,
So then we are doing a study then.
yeah. Reading these.
So
Yeah, so design the study is due Saturday, of week 8, and then collecting the data is due Saturday of week 10, describing the data Saturday of week 11, the inference Saturday of week 12, take action Saturday of week 12.
So it looks like we have a couple of weeks. So maybe we can just organize it this week. I don't want to do too much without Miranda here.
Yeah,
At our next group meeting, we can put that all together.
yeah, that could work.
But yeah, because it looks like we have one due this Saturday and then none next week. And then the week after that is when our next one's due. This Saturday, which is Thanksgiving weekend. Oh, do we have homework over Thanksgiving? We do. I'm gonna be so mad.
I think
Oh, no.
I think I might have a test that week.
Oh, gross. Okay. Well, guess cross that bridge when we get to it. I think we just have on that Tuesday. That's good. Okay.
It could also be like if we design a study, like we could do something possibly more simple if we just said like we have the same sports drink but we just changed the labeling on it or something
Mhm.
and see like which ones consumers are more likely to choose or something like that.
Yeah, that's a good one.
And then that way we won't have to test like blood glucose levels or something complicated, you know.
No, yeah, that's a good one. Or based on like the colors of the drinks or like the brands. Because sometimes colors, I don't know, like if you have a bright color versus a dark color, like orange versus purple,
Yeah.
people sometimes.
Or
Yeah.
I think we could also like each buy like a Gatorade bottle, like a blue bottle of Gatorade bottle, and like change the labels. Like so, one of them says like, "We'll give you superpowers," and then the other one says like, "We'll increase your stamina" or something, and we'll see which one, like which advertising works or something like that. I don't know. It's just an idea about like something like that.
Okay. That sounds good.
Okay, I'll try to think through that some more, and then hopefully it's
Yeah, we
better.
can. Let's all like think of a couple of ideas, and then we can bring them to the next meeting.
Yeah, for sure.
Okay. So should we start from today's lesson? Maybe?
Yes.
Do it.
We're on 16, right?
Mm-hmm.
Okay, I can start reading if you guys are ready.
Yep, I'm good.
Okay. In a pie chart, why are the slices/sectors different sizes? A. Pie charts are more visually appealing when the slices are different sizes. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category. That sounds pretty good to me.
I think it's that one, yeah.
I like number 1. That one sounds good.
Yeah.
It's visually appealing.
Yeah.
Okay, I can read the next one. How are bar charts and Pareto charts related? They are identical. Pareto charts are constructed from tossing a coin. The only difference between a bar chart and Pareto chart is that the bars in the Pareto chart are ordered largest to smallest, going from left to right.
That one.
That one.
That one.
Could read the next one. We conclude that P is normally distributed if NP is greater or equal to than 10 and N parentheses 1 minus P is greater than or equal to 10. Is P the true proportion or the sample proportion?
I
It's the true. Hold on.
want to double check.
I have
I want to say sample.
the P with the hat is the sample.
Yeah, if the sample size is large, the sample proportion P with the hat is approximately normally distributed. So sample.
So it's the P without the hat is the true proportion. Is that what we're getting at?
Oh, yeah,
Because that's what I'm pretty sure it is.
yeah, yeah. True proportion.
Okay. All right. What is N? The sample size, the number of successes, the number of candidates in an election. I think it's the
Sample
sample
size.
size. Yeah.
Alright.
If P is 1/4, what is the smallest N that satisfies the requirement? I think make it a fraction. 1 minus. Isn't it 1?
But I think wouldn't it have to be 4? It would have to be 4.
Yeah, because it's 1/4.
Yeah.
How are you figuring this out?
Because the P is actually like the proportion with the percentage, and if there's 1 out of 4, you'd have to have at least 4 people to get 1 out of 4 people.
Yeah.
Okay. That makes sense. Okay, cool.
Okie doke.
Alright. Use the following information to answer questions 8 and 9. Suppose n equals 24 and p equals 0.4. What is the mean of p? 0.4?
Need that equate.
Wait a minute. There's okay, wait. Gotta remember this.
Mean of P with the hat is equal to P.
P with the hat.
So P on the regular.
Yeah, because in
Equals
the reading it
X
says the
divided
mean
by
of p with the hat equals p.
Wait, the mean of P with the hat. It equals P?
Yeah.
Yep.
So it's just 0.4?
Well, yeah. I think so, right?
So I want to check the book to make sure I'm right.
Yeah, I'm looking right now. It says the sample proportion P with the hat is normally distributed if n is large. And n is large, right? N's 24.
That's not very large, is it?
No.
Yes. Okay, I found it. It's in the summary box. It says the sampling distribution of p with the hat has a mean of p without the hat.
Okay, let's just go with that.
Okay.
Then the standard deviation is down here.
P times 1 minus P divided
By n square root.
So P was 0.4, right?
Mm-hmm.
What was N, 24?
Mm-hmm.
I got 0.1.
I don't have my regular calculator. Here. Okay, here it is.
Yeah, I got 0.1 too.
Yeah.
Oh, I got a syntax error.
Hate that.
Yeah, I got 0.1.
Okay. Use the following information to answer question 10 to 13. Brittany's batting average is 0.3. We want to determine the probability she will get more than 35 hits in her next 100 at-bats. N equals 100 and P equals 0.3. So what is P?
What? P?
0.30.
Did we get that?
0.3? Oh, yeah, okay.
Yeah, because P of the hat is always equal to P for the mean.
But
Okay.
it's not asking for the mean, it's asking what is P.
Oh, hahaha.
Which equals x divided by n?
And
P times hat P equals x divided by n.
So
Oh, wait.
that would be
Oh, okay, yeah. X divided by
35 divided by 100? Does that sound right?
X, yeah, it's 35. So 0.35?
That's what I got. I don't know.
Yeah,
yeah, 0.35.
yeah. So then what is the standard deviation of P?
So P with a hat minus 0.3 P is
I got 0.046.
I got 0.00109.
No, maybe I did something
I
wrong.
get 0.048.
Okay, let's try again.
Something's wrong. Are you
Because
using the
Because it's 0.35 times 1 minus 0.35 divided
No.
by 100 and
It's-
square root.
P. So it's just 0.3. 3 times 1 minus 0.3.
Where did I get
Oh,
0.35?
Oh, I just did the z-score.
Oh.
I just did the z-score. That's what I did wrong. Oops. Okay, standard deviation is square root of P, which is 0.3, times 1 minus 0.3 divided by n, which is 100. So I got 0.0045.
I got 0.0458.
0.00458?
So you did the square root of 0.3 times 1 minus 0.3 divided by,
Divided by 100.
and then the square root of that.
Well, oh, it's the square root of the whole thing. I think I just did the square root of the top. Okay, hold on. Let me do it one more time. 0.3 times 1 minus 0.3 divided by 100. .0458. Yeah, okay. Yep.
Okay.
There we
So
go.
0.046.
Yeah. Okay.
Alright. And then, oh, and you just found the z-score.
Yeah, let me do it again, though, because I probably did it wrong.
So it would be 0.35 minus 0.3 divided by whatever 0.046.
I got 1.091.
I got 1.087. Let me try it again. The 0.35 minus 0.3.
I got 1.087.
Did you just use .046, though?
Yeah.
Because we rounded that.
Okay.
We shouldn't use what we rounded, I don't think.
So 0.045.
Well, it would be .0458
8.
at least.
Oh yeah. Okay.
Yeah.
I just hit 0.35 minus 0.3 divided by answer, which was the standard deviation. So
So 1.091.
yep,
Two?
that's what I got. Yeah.
Yeah. I got that too.
0.092.
I put 091.
Yeah, I think it's 9-1.
I got a 7 right next to the 1 in my.
I got a 0 right next to mine.
Yeah, when you do 0.04582, it gives you 1.0912.
Oh, okay. I just didn't add that extra number. The 1.091?
Yeah.
hmm
Okay.
And then this next question is where I was confused on the homework. But it says, what is the probability Brittany gets at least 35 hits in her next 100 at bats? Do we just do 35 over 100?
I think so. I think it's just 0.35, yeah. But that doesn't have 3 decimals. So the probability
We
should
wouldn't use the applet, would we? Since we have like the z-score.
Oh, maybe.
I think we could, but
Because then it
I
would
just don't know
show.
how.
And then it shows there's a 0.1376 probability of Brittany to hit 35 out of 100.
Yeah, because it says at least 35, so you do greater than.
So
Which would be 0.138.
wait, how do you do that? Okay, I don't get it.
So,
It's
because, yeah, go ahead.
No, you go ahead.
Okay, because we found her z-score, like the z-score of her hitting at least 35, we can plug that into the applet and say everything above 35 would be, or the probability of her getting at least 35 would be 0.138. If you just plug it into the applet and then just do everything above 1.091
So it would be 0.137.
or 138.
Okay.
I think
0.138.
so. I mean, that makes sense because if it wanted to know if she hits less than.
Yeah, it makes sense because I remember in the reading it was talking about like suppose like the politician stuff. Like it says, okay, suppose this many people voted for the Republican. If you divide it just normally, it was like 55%.
Mm-hmm.
And then later it says, okay, so this is supposed to tell us that technically the politician's supposed to win, but then they did like all the divide the standard deviation, the z-score stuff, and they used the applet.
Mm-hmm.
And then it says because we did all the math, and it only showed that the politician only had like a 0.18 something percent chance of winning, truly winning. So that's how it all makes sense to me, I guess.
Okay.
All right.
Hope that wasn't confusing or anything.
I think I'm okay. It was just weird at first. But
Yeah.
Okay.
It makes sense if they give us a z-score.
okay.
Okay, I'll read the next one.
Okay.
If the true proportion of people who support a political candidate is p equals 0.52 and if n equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of p?
Okay.
Here we go again.
So P times, wait, okay, 0.52 times 1 minus 0.52 divided by N.
I got 0.01117.
Yeah, that's what I got too.
117. Yeah, that's what I got. 0.011.
Yeah. And then what z-score would you use?
So it would be P. Okay, so P with the hat minus P. What is P with the hat in this case?
So we gotta work backwards.
P.
So x equal,
Would be fifth, like 0.50. Or, hold on.
P with the hat equals x divided by n. So if we know x and n, we can figure out P with the hat.
yeah.
And
But we
x.
don't know x, do we?
The only other number I see is just the 50%, but I'm pretty sure that won't be right.
Hold on,
Maybe.
okay. We do know the standard deviation and we know n, so maybe there's a formula with that in it.
Or, well, 50% of the votes is 1,000.
So would that be the x?
She gets less than 50% of the votes. I mean, that's the only number. Because then you get 1,000 divided by 2,000 is just 0.5. I mean, that looks close, like, because, like, in our other z-scores, it's always been close. Before it was 0.35 minus 0.3, and now it's going to be 0.5 minus 0.52.
That makes sense. Well, and also it is like a halfway thing, like 50% is a halfway, so that would make sense.
Okay.
So if we use those numbers, the z-score is negative 1.79.
That's what I got. 791.
I think
I think it's 0.790.
Did you put 0.01117?
I put 0.011171392.
Oh, okay.
I don't know if this will help because this is what I found in the book. It says, consider the following question. If the true proportion of people who support a particular political candidate is P equals 0.48, and if 1,041 people are surveyed, what is the probability that the results of the survey will suggest that the candidate will win the election? To address the question, we first note that the survey will suggest that the candidate will win if more than 50% of the people surveyed favor the candidate. So we need to find the following probability. First, we find the z-score, and they put 0.5 for the P with the hat.
Yeah,
And then,
so
minus.
That would make sense. That's what we got.
yeah, that's what you end up doing. I just went about it a little differently.
Oh, okay, good.
Yeah.
I think that correlates, yeah.
Yeah, what you do is, the way I found it was x over n, which was just 1,000 over 2,000, which is 0.5.
Oh, duh.
Yeah.
Yeah.
And then it would be a negative z-score because we're looking at less than.
Yeah.
Yeah.
Okay, so you got negative 1.790.
Yeah,
What is
negative 1.790. Yep.
Negative 1.790?
Yeah.
Okay.
Okay. So what probability do you compute using the normal probability applet? I'm not sure, but wouldn't it be the z is less than? Like the big Z is less than or equal to? Because we're looking at less than 50% of the votes.
Would it be the second one? Because, like you said, because we're looking at the z-score, but because we want to see if the probability of him losing the election, we would shade the applet to the left. That would be the bottom one because it has the arrow pointing to the left.
That's what I'm thinking. That's what I was thinking. I don't know.
Big Z is less than or equal to the sample size z-score, I would say.
Yeah. What does this? What is this?
What is this? Um, I don't remember that in any of the reading. Let's see.
I don't either. There's no such thing as Z.
Yeah, what is Big Z?
It was probably meant to put the P, because that's what the P's are. Because I found like the exact same parentheses and stuff. It has like the P with the hat inside where the Z should be. So maybe they just put the Z in for the comfort.
For comfort.
More extreme.
P parentheses Z less than or equal to. I'm gonna Google it.
Okay.
P. Why is the P like right next to it?
I don't know if it's like P times.
Probably just represents just the probability as a whole. Like, here's the probability, and then like so it's like probability of Z being greater than or equal to this other number.
Cumulative probability, because any normal random variable can be transformed into a z-score. The standard normal... What in tarnations? Oh my gosh, this is so confusing. Okay, hold on. There's definitely... It has it all over the internet. When you look up the probability in a z-table, is that the value less than or equal? What the heck?
Oh, okay. Are you looking at cumulative probabilities of standard normal distribution?
I'm looking at stackexchange.com. I don't even know.
This one here says left side area z-score is the P big Z less than little c. And that's the one we want, right?
Yeah.
I think it's less than, yeah.
Because it's asking to look for whether probability of the candidate losing.
Yeah, and then it says right-sided area is P, Z is greater than or equal to the little z. So I think it's...
The arrow pointing left.
Yeah, that's
Uh,
because, yeah, that makes sense to me because it's
so
asking.
the bottom one, right?
Yeah.
Okay. Okay, what is the probability the survey results will show the candidate is losing even though the true P is 0.52? Is it 0.03?
0.037.
Okay.
Yeah, 0.037, I think.
Okay.
Okay, is that it?
Yeah.
Okay.
One. Why did we miss one?
Should we... Okay. Are we, like, if you submit it, are you allowed to say which one is wrong? Or I don't know, like, what?
I don't know. I mean, I don't know what we did wrong on. It was number 7.
Oh. Maybe we can Google it. I'm going to Google it.
What is the smallest ad that satisfies the requirement?
Oh, wow, interesting. Okay. There's a very similar problem on the internet.
NP is greater than 10. Oh. Oh. You just used that formula. So it would be 40.
Wait, why would it be 40? Is that in the textbook?
Yeah, it's important to check both conditions. So what you have to do is you do n divided by, or n is greater than or equal to p 10 divided by p. And since p was 1/4, it would be 40.
What part does it say that in here?
3.21.
3.21.
How large is large enough?
Oh, okay. We can apply the central limit there.
And then you
And
can.
then 1 minus p.
Yeah, it'd have to be 40. Dang it. Well, there you go. You guys get one.
Oh, I already submitted it, so I got the.
Yeah. Have you submitted it yet, Kaylee?
No, but I will.
Yeah, see if that's right. 'Cause if not,
Okay.
I need to email her and say, why is this not right?
Yeah, that was right.
It was 40? Okay.
Yeah, it was 40.
All right.
Well,
Sweet deal.
yeah, good job, guys. Next time I'll be the guinea pig and I'll submit first. And
that works.
okay.
So yeah, just the next couple of days, I guess just be thinking about project ideas and then we can talk about it at our next meeting.
Okay, I'll probably
Sounds
just
good.
I'll try to look stuff up right now too, and then.
Okay.
Okay. Well,
Cool.
thanks, guys.
See you guys later.
Hey, have a good night.
See ya.
Yeah.
Good night.
Bye.